Hello everyone, I'm Professor K. N. Maksure, working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are going to learn the introduction of the gears. As we know, gears are playing very important role in all the equipments, right from the agriculture equipments to the spacecrafts. In our agriculture equipments, that means again in the automobile sector, again toy industries, again household equipments just like the mixer, then washing machine, again in heavy equipments, construction equipments, we'll find the application of the gears. Now we'll start with the definition of the gear. Gears are used for the power transmission. Power transmission is the movement of energy from its place of generation to the location where it is applied to perform useful work. That means that energy, in case of, suppose if you consider the two-wheeler, in that power is generated in the IC engine, and our task is to move that energy or that power to the rear wheel. The whole system from generation to the that given motion or power supplied to the rear wheel, which is the part of that power transmission, and that gear plays very important role in the power transmission. A gear is the component within a transmission device that transmits rotational force, which is the torque, to another gear or the device. Now that innovation in the gears start from these primitive gears. Earlier, that primitive gears are like this, which are used to transmit the power between two right angle shafts or the parallel shafts. Here, this part which is referred as which is plays role in the engagement, which is called as the cogs, or that gears are also called as the cogs. Here, right angle, and these are the parallel gear. Next, we already most of you have seen this movie. This scene is from the Bahubali movie, and I just want to show you how our ancestors are using, which are uses this gear technology at that time. I'll just play this video. We'll find that gears. Again, we'll find these are the cam follower. Okay. Now we'll start with the types of gears. According to the position of the axis of the shaft, there are the three subtypes. One is the parallel shaft, second one is the intersecting shaft, and third one is the non-parallel, non-intersecting shafts. In this parallel subsection, to transmit the motion between two parallel shafts, there are three types of gears. One is the spur gear, second one is the helical gear, and third one is the rack and pinion. In case of rack and pinion, that all the motion is transferred in the one plane only, but that rotary motion is converted into the linear motion. In case of spur gear and the helical gear, that rotary motion is converted into the rotary motion. This is the example of the spur gear. Second one is the intersecting shaft. When you are interested to transmit the power between two intersecting shafts, you will have the application of the Beaver gear. If these two shafts are intersects at the right angle, this is in this example, these two are, that shaft angle is of 90 degrees. Such type of gears we use the bevel gear. That angle may be less than the 90 degree. And the third type, which is the non-parallel, non-intersecting shaft. In this case, these two shafts are this is the one axis of this shaft, this is the axis of this second shaft, these two axes are non-parallel. That means these two are the perpendicular to each other, but these two are the non-intersecting to each other. In this case, these two shafts are intersect to each other, but in this case, these two shafts are non-intersecting. These are the three subsections. One is the parallel, intersecting, and non-intersecting. In the parallel, spur gear, helical gear. In the intersecting, bevel gears, and in the non-parallel, non-intersecting, worm and worm wheel, and the spiral gears. Again, according to the types of gears, the first type, which is the low velocity, if the velocity of the gear which is the less than 3 meter per second, which is the low velocity gears. Second, if that velocity is in between 3 to 15 meter per second, then it is medium velocity gears. And the high velocity gears when that speed is more than the 15 meter per second. In case of the power generation or in case of turbines, we use the high velocity gears. Next, according to the type of gearing, first one is the external gearing. External gearing means these two gears are made externally. In this case, when this gear rotates in the clockwise direction, this gear rotates in the anti-clockwise direction. This is the external gear. Second type, which is the internal gearing. In this case, suppose this gear rotates in the clockwise direction, the second gear which also rotates in the clockwise direction. Suppose it rotates in the anti-clockwise, this also rotates in the anti-clockwise direction. That means two mating gears are rotates in the same direction when there is a internal meshing. And third type, which is the rack and pinion. In this case, that rotary motion is converted into the linear motion, or linear motion is converted into the rotary motion. In all these three type of gears, anyone may be the input. This may be the input or this may be the input. As we give the input to this, which allows to rotate this. If we give the motion to this will rotate this. Okay, these two types of gearing. In these two type of gearings, that rotary motion is converted into the rotary motion. But in this case, when this red gear, which is called as the pinion, which is having the rotary motion, and that rack which is having the linear motion, if that pinion is the input, that rotary motion is converted into the linear motion. If that rack which is having the linear motion, when it becomes the input, then that linear motion is converted into the rotary motion. Now we'll see the spur gear. That spur gear, which are having the which is very commonly used gear, which is having a lot of application in all the type of applications. That means in the agriculture equipments, automobile industries, everywhere. The spur gear, in which that these teeth, the orientation of these teeth, which is parallel to the axis of rotation. All these teeth are parallel to the axis of rotation. Okay, second, again, which is used to transmit the power between one shaft to another shaft, which are used in the electric screwdriver from our basic application, then oscillating sprinkler, alarm clock, washing machine, load dials, or in the automotive gearbox. Also, you will find the application of the spur gear. Here we are just going to learn the basics. You should understand that mechanism, or you can classify that gear just by viewing the gear. You have to just recognize which type of gear is this, whether it is spur gear or helical gear. Just viewing this, you have to recognize that theory we are going to cover over here. Okay, the advantage of this spur gear, they offer constant velocity ratio. Yes, they offer the constant velocity ratio. Second one is they are very highly reliable. Then they are easy to manufacture, easy to design. They are the more efficient. They are having the highest efficiency as compared to all the types of gears. Again, spur gear, these teeth are parallel to the axis. Again, there is no any axial thrust that we are going to discuss in the subsequent sections. there is no any axial thrust, and they are used to transmit the very large amount of power up to the 50,000 kilowatt. Next one is the disadvantage of these gears. They are used in the slow speed application because of there is these teeth are parallel to the axis of rotation, and because of parallel orientation there is a sudden contact between two gears, which creates the noise. To avoid the noise, we have to use this in the slow speed application. Again, that teeth experiences large amount of stresses, that also we'll discuss. Again, we can't transmit the motion between non-parallel shafts. They can't be used for the long distance power transmission. Spur gears produce a lot of noise when, yes, that we already studied, and when compared with the other type of gears, they are not as strong as them. Okay, the second one disadvantage of this spur gear. Second type, which is the helical gear. In the helical gear, you can see that this is the axis of rotation, this is the axis of rotation, and that teeth are inclined to the axis of rotation. This angle is called as the helix angle. This angle is called as the helix angle. Again, because of this helix angle, that contact starts with this point and ends with this point. That means contact starts with the point contact and ends with the full line contact. That's why there is a gradual engagement between two teeth. That's why these gears are used for the high speed applications, and okay, and they create the very less noise. Okay, again, if the angles of the gear teeth are correct, they can be mounted on the perpendicular shafts, adjusting to the rotation angle by the 90 degrees. Yes, again, if these two gears having the same angle, that means if this helix angle alpha is of the 60 degrees or the 30 degrees, and again meeting gears which is again having the 30 degrees, we can transmit the motion between two right angle shafts, which becomes the spiral gear. We can make it as a spiral gear. Advantages: they run very more smoothly and quietly. Helical gears are highly durable, which are suitable for the high load applications. The result, that means that contact starts with the point, ends with the line. That's why there is a less wear as compared to the spur gear. They are used in both the application, either to transmit the power between two parallel shaft or the right angle shaft. This becomes the spiral gear. Disadvantages: because of that orientation of this tooth with that axis of rotation, we need to add thrust bearing, because which adds extra force along the axis of rotation. That means we have to add one new component, which is the thrust bearing. Again, helical gears cause losses due to the unique geometry along the axis of helical gear shaft. Again, efficiency of the helical gear is less because of the helix gear train have the sliding contact between the teeth. As we know that contact starts with the point, ends with the line, and because of that you will find the sliding, and which reduces, because of that frictions come into the picture, and which reduces the efficiency. Now this is again one advancement in the helical gear, which is a herringbone gear. In this, to avoid that thrust, we need to add, or we need to edit the geometry, or we need to make the modification in the geometry. You will find these are the two helix gears. We have just joined the two helix gears, and which of having the same angle. If you draw one line over here, this makes the alpha plus alpha, and second one is the minus alpha. With the help of this, that herringbone gear, we can avoid the thrust acting on this, and which are used in the very heavy industry, very heavy machinery, to reduce noise and take the very high loads. Next one is the rack and pinion. Rack and pinion, which are used to convert that rotary motion into the linear, or linear motion into the rotary motion. You will find the application of in the drilling machine. Again, in the steering gear mechanism, you will find the application of rack and pinion. Then we will discuss the advantages and disadvantages. Advantages, which are cheap, cost is low, compact, robust in nature, easiest way to convert rotary motion into the linear motion. Again, disadvantages. The rack and pinion can only work with the certain level of friction. For the too high friction, and the mechanism will subject to the wear, which causes the wear, and due to the inherent friction, we need to change these gears, or the gear, or the pinion, or the rack and the pinion. Next one is the bevel gear. When we are interested to transmit the motion between two right angle, or the angle less than the 90 degrees, we need to use the bevel gears. There are three types of teeth in that bevel gear. One is the straight, spiral, or the spiral and the hypoid. You will find these gears come into the category of intersecting shafts. These two gears, if you consider their axes, these two axes are non-parallel but intersecting. These two axes are not parallel to each other, but they are intersecting at a common point. That's why this is to transmit the power between intersecting shafts, we need to use these pivot gears. Again, their applications you will find in the marine applications, automobile, printing presses, cooling towers. Everywhere you will find the application of these bevel gears. This is the straight bevel gear. These are the spiral or the hypoid bevel gears. Advantages: quite operating noise, having the good torque transmitting capacity, and having high efficiency. Again, the disadvantages, these are due to their nature of their teeth, that manufacturing cost is high. Again, they need to manufacture into the pairs. That means if one gear may get fails, its counterpart should be, again we need to change. Again, limited translation range. That means again maximum ratio is of the 6:1 for the given bevel gear set. Again, these gears are not recommended for the high speed reduction, or for the high speed they generate the noise. Next type, which is the worm and worm wheel, which comes into the category of non-parallel, non-intersecting shafts. In this case, these two shafts are perpendicular to each other, but these two are not intersecting to each other. This part is called as the worm, and this called as the worm wheel or the gear. You will find worm and the gear. Again, worm gears are used when the large gear reduction are needed. When we want the gear reduction up to the 300:1, that means when this worm completes the 300 rotation, at the end of 300 rotation, this completes its first revolution, or the 20:1. Many worm gears have the intersecting properties that not other gear set has. The worm can easily turn the gear, but worm gear can't turn the worm. This is very, very, very important. That worm in this case, in earlier cases, in case of spur gear, helical gear, beaver gears, we can interchange the input. We can make the anyone as the input. But in the worm and worm gear, every time worm is the input and worm fill is the input. This is because of its inherent properties. These are used in the cranes. Again, in case of lifts, we use such type of gears. In this case, we can't transfer the motion from worm wheel to worm. Every time we have to transfer the motion from the worm to worm wheel only. The application of this worm and worm wheel, material handling, transportation industry, material tools, or the automobile industry, etc. The advantages, again, smooth and silently operated. They are having the inherent property which is the self-locking. You can transmit the motion from the worm to worm wheel. We can transmit the motion from the worm wheel to worm. Again, very compact. Again, having the good meshing effectiveness. That used for the reducing the speed and the increasing the torque. Again, near about here I mentioned the 100, but we can reduce velocity ratio. We can obtain 300 as to 1. Again, worm, while designing the worm and worm wheel, that worm gear, that material should be, which is very expensive. That material is of the copper, which is very expensive. Again, there are very high power losses because of the friction. Again, because of that sliding action, which reduces the efficiency, and which that gear, because of the friction again, which produces the lot of heat. Now we'll study the application of the gears in the automobile industry, toy industry, factory automations, packaging industry, industrial robots, in their motors, in the IC, DC, stepper, servo, everywhere in that motors we use that gears. Next, food processing machines, car production machines, machine tool industry, material handling equipments, printing machine, automatic cutting or the welding machine, machine for the medical or the cosmetic fields, construction machine, food or glass processing machine. Everywhere you will find the application of the gears. Again, last one, which is very important, which is the agricultural machinery, you will find the application of the gears. Now, last part of this lecture, which is the gear materials. Depending upon the strength and the service condition like wear and noise, we have to select the material. There are two types of, that means, materials we use. One is the metallic and second one is the non-metallic type materials. In the non-metallic type materials, we use the wood, raw hide, compressed paper, or the synthetic resin like nylons, which are used in the our electronic components. Again, in the toys, we use this non-metallic type. Again, in the automation industry, we use these non-metallic type materials. Again, in the metallic type materials, we use the cast iron, which is having the low cost, is of producing complicated shapes, excellent machinability, and good wearing properties. That's why, which is again best option for the gear manufacturing. Again, for the high strength gears, we use the steels, stainless steel also we used, or the mild steel. Again, these gears are usually heat treated in order to combine the property of toughness and the tool hardness. Again, we use this phosphor bronze, which is used for the worms to reduce the wear of the worms, which will be the excessive with the cast iron or the steel. With this, what we learn in this unit, we learn the classification of gear according to the orientation of gears, orientation of the axis of gears. There are three basic type. One is the, that means if you want to transmit the motion between two parallel shaft, we have the two choices. One is the helical gear and second one is the spur gear. If you want to transmit the motion between two intersecting shafts, we have again one choice, which is the bevel gears. And if you want to transmit the motion between two non-parallel non-intersecting shafts, we have to use the worm and worm wheel. Again, we have studied the different materials. There are two types of material. One is the two basic, one is the non-metallic and one is the metallic. In the non-metallic, we use the normally nylon or the plastic gears are used in the electronic equipments, and in the toys we use these non-metallic gears. Again, in case of metallic, one is the cast iron, which is used because of its ease of manufacturing and its cost. Most of time we use these gears. Again, second one is the our steel, mild steel or the stainless steel, and third one is the phosphor bronze, which is used as a material for the worm in case of worm and worm wheel. With this, thank you for your patience listening. Thank you.